like I said before, you all started the opener. First step in factoring will always be look for greatest common factor. And the reason I want that to be the first step is because if that's the only thing that needs to happen, which sometimes to factor a quadratic, we might just need to take out a GCF and be done. Okay, so if that is our habit to look for greatest common factors first, we'll catch those. Okay, we'll catch the equations that do factor just by simply taking out a GCF. So with the first opener here, 8x squared minus 22x plus 5, there's no greatest common factor there. Okay, and that's going to happen every now and again, right, where there isn't a GCF. Just when we find them, it either, one, makes it a lot easier, or two, is really all that we need to do. Okay, so no GCF there. Looking for two numbers that add to negative 22, add the 40. Those numbers are negative 20 and negative 2. After plugging everything into the area model and finding the outsides, you find that the complete factored form is 4x minus 1 times 2x minus 5. And remember, what we read as our factored form should always equal what we started. And we could check this by multiplying it out, which we basically did by working with the area model already, right? The checking is built into that. All right, then the second problem. I do notice that there's a GCF there of 3. All those numbers are divisible by 3. If you don't factor out the 3, that's okay. Okay, I'm going to show you the other answers that you might get if you don't take out that 3. But when I take out the 3, now I'm looking for two numbers that multiply to negative 12 and add to negative 11. That's a much easier task than trying to find numbers that multiply to 18 and times negative 6. Well, that was like negative 100 and something. And then add to negative 33, that's not a hard or an easy thing to find. Okay, so the GCF of 3 makes it a lot easier here. And you should get to a final factored equation of 3 times 6x plus 1 times x minus 2. Now, just a reminder, if you did not take out the greatest common factor, what your answer might be, it might have this 3 just multiplied into one of the factors. So you might also have it as 18x plus 3 times x minus 2. Or the 3 might be multiplied to the x minus 2. So it could also be 6x plus 1 times 3x minus 6. All of these represent a factored form of the original quadratic. Okay, so as long as you have one of those 3, you've got the right factored form here. Okay, any questions here before we jump into what's going to be our last lesson? Okay, we'll add one step to this on Monday, but the last thing in this unit. No questions here? All right. So far, everything that we have factored has been quadratic. Now, I want us to write very clearly that quadratics, I don't know that I've done this quite yet, but a quadratic, the largest term is x squared. That's what defines something as being a quadratic. So if we have this expression and we see an x squared in there, and there's no other x with a bigger exponent, that defines it as being a quadratic. We need to see the x squared and no exponent bigger than that too. When it's a quadratic, we will always, to be able to factor it, have to do the a times c and add to b. What we're going to work on today is factoring cubics. Okay, so something that is to the power of 3. So let's make a note of that as well. So a cubic, the largest term, is x cubed. Now, what's nice about the cubic functions I'm going to ask us, or the cubic expressions I'm asking us to factor, there's already going to be 4 terms. So we don't need to do any a times c and add to b. If we've got 4 terms, we can just jump straight into the box and start to factor. So today's lesson is going to feel actually, in my opinion, a little bit easier than the quadratics because we're not having to do the a times c and add to b. All right, so the only thing we need to learn is how to set up the area model. Then we do everything just like what we did before. And so let's try right now. So like I said, largest exponent here is a 3. This makes this a cubic. Yes, there is a quadratic term in there, but the largest exponent is what is defining this as being a cubic. I notice that I have 1, 2, 3, 4 terms. So everything can go in that box. We've got a place for every single term. We will always put the cubic term in the top left, the constant term in the bottom right, very similar to what we do with quadratics. The other two terms, it does not matter where we place them. So I've got negative 6x squared and 8x. And now the only thing we need to do is find the outsides, which is really us doing the factoring. Again, there are two ways that we can figure out the outsides. We can think about greatest common factors in each column and in each row, or we can think about multiplication. Again, I like the multiplication a little bit better because I think it helps pick up on the signs. And just like before, I'm going to think about how can I multiply to get x cubed? Well, if I'm only taking two terms to multiply to get x cubed, it has to be an x and an x squared. So I want to place the x squared so I can multiply it to get to the negative 6x squared. So for me, that's on the side. That makes the top an x. So right now I have my x and x squared to get to x cubed. Then x times a positive 8 is 8x. And then x squared times negative 6 is negative 6x squared. And negative 6 times 8 is negative 48. So we are all done. This factors to x squared plus 8 and x minus 6. Right? Even quicker than the quadratic part. All right, let's do one more. And then I might just let you all work through the rest of these. So just one last time. You will always take the cubic term, put it up top, top left. You'll take the constant term, put it in the bottom right. The other two, it does not matter where we place them. So negative 7x squared and 7x. Now we're going to think, how can we get to x cubed? To get to x cubed, we got to do an x squared times an x. I'm going to put x squared so that it multiplies to give me negative 7x squared. So that makes the x up top here. So x squared times negative 7 is negative 7x squared. X times positive 7 is 7x. And 7 times negative 7 is negative 49. So this factors to be x squared plus 7 times x minus 7. And we're done. All right, go ahead and flip the page over. And I don't know what I'm going to have us do all of these. Maybe we pick like 3 or 4. All right, for now, let's just do 3 and 4. Okay, everyone do 3 and 4 on your own or in your groups. Make sure you're setting it up the same. You can still look for greatest common factors to start. That should still be our starting points. If there's a number that divides everything, it just makes it a little bit easier. All right, I'll give you a couple minutes to try 3 and 4. Okay.
So I was up there looking for it. I went to the console.
You're right. That's no sheet.
Did you find it? No. No, I was looking. Really find it. Yeah, like a trouble. Where did you lose your backpack?
Thank you.
We got testing. And I had snacks.
We'll just work through 3 and 4, and we'll probably just make these the last 2. I don't know that we need to do more. If you did more, good job. You got more practice. All right. With these, there's really only one right answer, unless you completely change the signs on everything, and like you're taking negatives out when it should be positive. But you should end up getting 5x squared plus 4 and 4x minus 7. There's really no other way to get that. One other question I get asked fairly often is, does it matter which factor we write first? No, it doesn't. Not at all. Okay, you could write 4x minus 7 times 5x squared plus 4. It's all the same. And then here on number 4, you get 4r squared minus 1 times 3r minus 8. If you're not able to get these, let me know. I'm going to come do a homework check, and I can kind of help walk you through these two. And then, yeah, I'll come around, I'll pass out the homework, and the rest of the class will be homework time. I'll check homework,